This is Dr. Lewis, just going over some of the topics which will be covered in the assessment to replace the written exam, which, as you know, is basically the same exam except you do all the questions. Remember that my course on structure and reactivity was rewritten this year. So if you look at past papers thinking my question will be similar to previous years, there are parts of them will be the same, but some topics will not be there, such as VSEPR theory will not be there, and molecular orbitals of molecules such as nitrogen and oxygen, that won't be there. But this question has appeared very much similar in previous papers. So this covers the topic in the PowerPoint called L1, structure and bonding, and where we went through quantum theory and its developments, which led to the shapes of the orbitals S, P, and D, etc. So it says complete the following table of quantum numbers. Just to remind you, I've put the key things below. So n is the principal quantum number, which starts at 1, 2, 3, 4, 5, and that's basically going down the periodic table and refers to the energy levels the electrons go into, and as you go down the periodic table, the energy levels get higher and higher as you fill them. L is the azimuthal quantum number, which is can only be 1 less than n. So if n equals 3, for instance, L could be 2, 1, or 0. And the azimuthal quantum number is associated with the angular momentum of the electron in the orbital. And for L equals 0, there is no angular momentum, and we have a spherically symmetrical orbital, which is the s orbital. And then we go to L equals 1, which is the p shape, and then the d's of L equals 2. ML is the magnetic quantum number, and that can take values from plus L down to minus L through 0. And that is associated with direction of the orbitals. So remember, the p orbitals can have 3 directions, so there are 3 magnetic quantum numbers. So for L equals 1, that's the p orbital, it could be plus 1, 0, or minus 1. But for L equals 0, ML can only be 0. MS is the one that's not really taken into account in this table. It's the spin quantum number. So remember that the spinning electron, if you think of it as a spinning charge, gives rise to an angular spin angular momentum, and the value for an electron can be plus a half or minus a half. And we fill the orbitals, and as we do so, we pair the spins. But that doesn't really affect filling in this table. So the first one in the table has n equals 2, L equals 0. So ML can only be 0. And orbital designation, remember, is first the principal quantum number, and then the name of the orbital is the next one, is the L value. So for L value of 0, that equates to our letter S. So the number of orbitals is going to be 1, because there's only one value of ML. The next one down has blanks until the orbital designation of 3p, so that immediately tells you the energy level, which is 3, the principal quantum number is 3, and for p that equates to an L value of 1. So if L is 1, remember if you go down, ML can only have values of plus L down to minus L, so that can be 1, 0, and minus 1, and therefore there are 3 values, so 3 orbitals, 3 p orbitals. The next one has n equals 3 given, and it says there are 5 orbitals. So remember, the only way we can get 5 orbitals is when L equals 2, and therefore ML is 2, 1, 0, minus 1, minus 2. So that tells us that L equals 2. And therefore the designation is going to be 3D. So D equates to L equals 2. And the final one, given N equals 2, L equals 1. Therefore, just like above, L can be 1, 0, or minus 1. The designation is first the principal quantum number and the letter equating to L equals 1, which is P, and as above there are 3 p orbitals. So that's the level you need to for that question. So you're not asked to describe anything about quantum theory, just to remember those simple rules.